The hypothesis of ancient inestimable explosion is, by and large, recognized by most specialists as the fundamental explanation for the beginnings of the universe, encompassing the development of stars, planets, and all life, including us. Not enduring its reasonably eccentric name, the term huge explosion properly captures the monstrosity of the event. At first, the universe was a thick combination of particles squeezed into a space more modest than a pinhead. From this point, a tremendous impact of issue happened, known as the enormous detonation. This succinctly summarizes the communication that unfurled over billions of years. Anyway, no matter what the persisting acclaim of the hypothesis of how things came to be, movements in logical information have continuously tested its expectations. When NASA shipped off the James Webb Space Telescope, the biggest and most advanced space observatory to date, researchers theorized that its perceptions would build up the hypothesis of ancient grandiose explosion. Sadly, after only 1 year in space, the telescope has astounded specialists with its earth-shattering capacities, giving phenomenal looks into the universe's past. The James Webb Telescope's exposures have uncovered systems so old that they could, in fact, reshape how we decipher the universe's beginnings. This unforeseen revelation has ignited serious interest among scientists and fans alike. One such significant revelation came when stargazer Rohan Natu, breaking down early pictures from the James Webb Telescope, incidentally tracked down a system that astounded everybody. This universe, named Glass Z13, appeared to be strangely tremendous and traced as far back to just a brief time frame after the enormous detonation, making it more established than any previously seen world. Nata's energy was unmistakable as he conferred the discovery to partners in the world, describing it as past anything cosmologists might at any point envision. The James Webb Telescope, situated a long way from normal impedance and outfitted with best-in-class technology, was designed to jump into the universe's earliest age, known as Grandio Dawn. This period, shrouded in mystery, means the arrangement of the universe's most noteworthy stars and galaxies. By analyzing systems from this period, specialists hope to refine how they decipher major grandiose cycles, like the effect of dark matter and dark energy. Starting presumptions for the James Webb Telescope's revelations were unassuming, anticipating a long time away galaxies. Anyway, the truth outperformed all projections. The telescope's photos uncovered frameworks of astonishing development, testing existing models and inciting a tornado of assessment. As scientists continue to take apart the James Webb Telescope's information, the implications of these disclosures could be huge, presenting a new time of cosmological perception. The astonishing revelations from this essential observatory offer an enticing investigate the universe's past, driving humankind's excursion to unwind the privileged insights of existence. As early frameworks appeared, researchers and onlookers wound up in a scramble to figure them out. Could this collection of strangely colossal and brilliant early universes at any point be whimsical? Maybe due to defects in the assessment of the telescope's underlying discernments, or, on the other hand, if valid, could they somehow be obliged with standard cosmological models? Potentially, were they the principal means that the universe is more peculiar and more intricate than our boldest hypotheses had expected? The question is nothing less than how we could decipher how the exact universe we know emerged out of beginning phase disarray. The early revelations from the James Webb Space Telescope might perhaps amend the underlying pieces of grandio history. These segments worry far-away ages in far-off frameworks as well as our own presence here in the normal smooth way. As Mark McCarran, a senior advisor for science and investigation at the European Space Office involved with JWST, remarked, "You construct these machines not to certify the perspective but to break it. You simply don't have the haziest thought how it will break." JWST's view of early universes has been billions of years really taking shape. However, more unpretentiously, they trace back to the Space Telescope Science establishment in 1985. Around that time, the Hubble Space Telescope was at this point a long time from farewell. Anyway, ever the foundations, then Chief Ricardo Jan mentioned that his gatherings start pondering what could come after Hubble significantly further away. Paying little heed to beginning quarrels over focusing in on Hubble, Jan was tireless, foreseeing the broad turn of events. Fellow Waite, then representative administrator of SD Sky, alongside a small gathering, began drafting contemplations for what eventually transformed into the Forefront Space Telescope, later renamed JWST. They noted that while Hubble would be historic, its abilities would be confined by its discernments in recognizable light. The JWST, on the other hand, would find in the infrared range, allowing it to enter further into the universe. The requirement for JWST became significantly more clear in December 1995, at the point when cosmologists coordinated the Hubble Deep Field discernment. Regardless of presumptions for tracking down a few faint inestimable frameworks, the ensuing picture revealed a colossal number of galaxies reaching back more than 12 billion years into the universe's arrangement of encounters. After north of 20 years of progress and at a cost of around $1 billion, JWST was finally shipped off on Christmas Day 2021. The telescope went through careful testing before showing up at its significant space objective a month sometime later. By July 2022, it was ready to start its long-awaited first year of science discernments, known as Cycle 1. Some part of JWST's beginning mission was given to high-effect programs, including the Cosmic Development Early Delivery Science Overview and the GRIS Point of Convergence Enhanced Outline from Space, both highlighted uncovering understanding into the mysteries of the early universe. As stargazers straightforwardly gave vast hours to checking independent patches of the sky, searching for ahead-of-schedule universe infinite frameworks, they from the outset expected humble revelations, like a more detailed variation of the Hubble Deep Field. Regardless, they were in for a shock. Stephen Bladlin from the School of Texas at Austin, leading the SE project, seems okay that extremely distant frameworks should emerge exclusively after various data cycles from various undertakings. Anyway, to cosmologists' wonder, these universes appeared rapidly. The record for the most far-away known framework had a spot with GNZ 11, seen in 2015 with a redshift of 11. Redshift gauges the extending of light as a result of the universe's development, with a higher value exhibiting greater distance. Yet, from the earliest reference point of Glass Insight's two separate gatherings, including one led by Rohin Natu, freely recognized Glass Z13 with a redshift of 13, driving the timeline back fundamentally further. In their scramble for speedy results, experts relied upon worked-on methods for redshift evaluation in light of brightness assessments rather than extra time-consuming direct assessments. Disregarding their ease, these assessments revealed universes unexpectedly splendid and tremendous, some previously parading a glorious mass rising to 1 billion suns, similar to our own. The energy didn't stop there. In the resulting days, various universe contenders from Sears and Glass emerged, some with redshift measures as high as 20, exhibiting they existed just a brief time frame after the gigantic explosion. These universes showed circle-like plans not expected in such early galactic ages. Moreover, another gathering tracked down evidence of smooth squander frameworks at a redshift of 10, under 500 million years after the gigantic explosion. Such a quick rise of sizable universes challenges the assumptions for the standard cosmological model, lambda cold dark matter. To get a handle on this peculiarity, a brief get back to early universe components is basic. In the fundamental minutes after the gigantic explosion, the universe was a hot, thick soup of right-on-time stage particles. Over the long haul, as the universe broadened and cooled, helium and other light parts outlined, inciting the presence of the head particles close to 400,000 years after the reality, around 100 million years after the colossal explosion, conditions became supportive for the improvement of the chief stars, made basically out of hydrogen and helium. These early stars, greater and more awesome than current stars, amassed into proto-universes, coordinated by the gravitational draw of faint matter. Anyway, JWST's disclosures challenge this model as it reveals marvelous sizable cosmic frameworks far sooner than expected. Stacy M. from Case Western Reserve University saw the surprising setback of different more unobtrusive protogalactic parts, recommending that some notice frameworks may be nearer than expected, concealed by dust and appearing to be dimmer and more distant. The divulgence of the early universes raises huge issues about the universe's beginning phases, featuring the requirement for continued with examination and revision of our cosmological models. Follow-up insights of Glass Z13 in August 2022 by the Atacama Large Millimeter Array in Chile project vulnerability on the basic disclosures. No matter what the usage of brightness-based assessments, ALMA didn't perceive basic proportions of buildup related with Glass Z13. As P. Tom B. from Goya School, who led the insights, said, "This proposes that low redshift gatecrashers can be prohibited, yet ALMA endeavored to perceive the universe by any means. This highlights the trial of insistent insights made using JWST's high capabilities." Rohan Natu, one of the experts being referred to, raised the incongruity of the situation, communicating, "The inspiring news is there's nothing distinguished." He said, "The awful news is there's nothing distinguished to just. JWST is fit for returning again to its own insights. The most ridiculously alarming explanation could be that the norm LCDM cosmological model requires refreshing." Michael Bohan Cullen, a cosmologist, imparted the size of this expected change in perspective, communicating that, "These results are very shocking and challenging to get in our standard model of cosmology. It would be a certifiable rebellion to grasp the one sketchy suggestion is changed Newtonian components, which challenge the presence of dark matter. JWST insights could lend sponsorship to MZ proposed by Mark McCarran. Anyway, not all cosmologists are convinced of M's legitimacy. Another possible clarification is that early universe galaxies could have practically no buildup, making them appear more mind-blowing and affecting mass calculations. The circumstance could similarly get a handle on ALMA's trouble in perceiving glass Z13. Charlotte Brickley and her partners proposed that JWST could be seeing the most magnificent energetic frameworks in the early universe, which could propose essentially star arrangement conditions during that age. David Spergel upholds this idea, suggesting that high-mass star development might have been more capable in light of higher gas strains and temperatures, possibly affected by early fascination fields. The fast dispersal of coherent papers from JWST's introductory discernments reflects a shift toward progressing friend study via stages like a 14 in virtual diversion. While this speeds up the dissipating of revelations, there are stresses over rushing to conclusions before serious friend review, not enduring arrangement issues and potential recalibrations impacting the fact that all makes scarcely any results. It is inconceivable. High redshift enormous frameworks saw by JWST will be invalidated, taking everything into account. The sheer number of these universes suggests that the early universe may be not equivalent to what was previously expected. Bladlin imparted trust in the legitimacy of the exposures, communicating that the possibilities of cosmologists being through and through base are little. As of now, stargazers are rushing to coordinate resulting discernments with JWST. Nancy Levinson is at this moment assessing around 12 suggestions from various gatherings, searching for extra JWST viewing time, primarily to inspect high redshift inestimable frameworks, promising new kids in town. Given the energy and importance of these early revelations, certifying them is fundamental. Troy, who introduced one of the proposals, highlighted the meaning of avowing these revelations. Unique projects like Universe Web, led by K2T, hope to grow the known people of early frameworks by seeing a more broad area of the sky for some hours. Generally, they expected that they could recognize great numerous frameworks. Other than additional endeavors, they will search for verification of the fundamental proto-universes, possibly using the shaky passings of supersized first stars and brilliant grandiose blasts as markers for their existence. A couple of assessments suggest that JWST could notice enormous frameworks to the degree of a redshift of 26, just 120 million years after the gigantic explosion. Asserting, indeed, even a little pack of these high redshift up-and-comers would be a great achievement, as demonstrated by Natu. This shows that cosmologists are not being weakened by their insights. JWST has presented one more time of science, and no matter what the weaknesses, the fast correspondence of new data has animated stargazers. Troy communicated energy about the associated with and stimulated scholastic neighborhood. As of now, the request arises, is now the perfect opportunity to re-examine how we could decipher the earliest reference point. The huge consequences of investigating the neglected world finish up the information. For the time being, make sure to show your assistance by inclining toward purchasing and then blending things up around the town for future episodes. Likewise, make sure to share your examinations on the current substance. Your assistance motivates us to continue to convey quality substance and to take continually a wound at progress. Appreciation for watching, and we'll see you at some point. All in all, the James Webb Space Telescope, JWST, has introduced another period of investigation and disclosure, testing how we might interpret the universe's starting points and development. Its exceptional perceptions of cosmic systems shaped presently after the huge explosion have ignited fervor and discussion among researchers, pushing the limits of cosmological information. The telescope's capacity to peer further into existence than at any point before has revealed infinite peculiarities that resist regular models, provoking a reassessment of existing speculations and the detailing of new ones. From antiquated worlds to the secrets of dark matter and early star development, JWST discoveries have significant ramifications for how we might interpret vast history. Looking forward, JWST vows to keep unwinding the universe's intricacies, offering looks into stories already past our reach. Its revelations not only advance logical request but also rouse wonder and interest in the universe's immeasurability and our place within it. As JWST sets out on its mission to additionally investigate the universe, researchers anxiously expect what new disclosures lie ahead. With each perception, we draw nearer to unwinding the principal inquiries of presence and acquiring a more profound enthusiasm for the woven artwork that encompasses us. Generally, the James Webb Space Telescope stands as a demonstration of human interest and inventiveness, driving us toward a more profound comprehension of our grandiose starting points and our spot in the universe's grand account.